Hello everyone, this is Harleen Kaur and today we are going to talk about discovery of electron, proton and neutron from structure of atom class 11th. Electron, proton and neutron, as we already know, are the fundamental particles of an atom. Any atom must carry these electrons, protons and neutrons. And the agenda of today's video is to discuss how electrons, protons and neutrons were discovered. So first of all, we are going to talk about discovery of electron. 1879, William Crookes carried out an experiment in which he took air in a discharge tube, which is basically nothing but a glass tube and is almost 60 centimeter in length. So in a discharge tube, William Crookes took air and metal electrodes were attached to it on the extreme ends of these. These metal electrodes were then connected to a high voltage generator or a high voltage battery. The electrode which is connected to the negative terminal of the generator is itself negatively charged and is called cathode, whereas the electrode which is connected to the positive terminal of the generator is positively charged and is called anode. You can also see a vacuum pump in the figure. This vacuum pump helps to regulate the pressure of the air or regulate the pressure of the gas taken in the discharge tube. We can increase or decrease the pressure of the gases. However, the experiment was carried out at a low pressure. So, when high voltage generator was allowed to supply current to the metal electrodes, it was found that some rays were emitted from the cathode side and they started moving towards anode side. Now, since the rays are moving towards anode, which is positively charged, it is assumed that the particles of the ray must be carrying negatively charged. That is why the particles of the rays are getting attracted towards positively charged anode. So in simple terms, what happened was when current was supplied to the system, the rays from the cathode, they started moving towards anode. But of course, we cannot see this by naked eye. So what he did was William Crookes made the anode porous. Now what do we mean by porous? Porous means he produced some holes in the anode. So when there were some holes in the anode, the cathode rays would cross that anode and they will strike the discharge tube. And at the discharge tube, he placed a zinc sulfide layer. When these cathode rays moved towards anode, due to the holes in the anode, they crossed the anode and they strike the zinc sulfide layer. And when this strike happens, a green glow was produced. This green glow is known as fluorescence, and this helped to understand that there are certain particles or there are certain things in the discharge tube that are moving from cathode side to the anode side. So the experiment was very simple. Let us just understand once again. What William Crookes did was he took a discharge tube in which is basically a glass tube, and in that discharge tube he placed two metal electrodes. One was connected to the negative terminal of the battery and other was connected to the positive terminal of the battery. The negatively charged terminal was connected to cathode and positively charged terminal was connected to anode. The function of the vacuum pump here is to regulate the pressure of the gas taken in the discharge tube. Since the rays are moving from cathode to anode, this was assumed that the cathode rays must be carrying particles which have negative charge on them. then only they are getting attracted towards the positively charged electron. So whatever we have done, let's just read it once again. Moving on to the characteristics of cathode rays. So cathode rays are negatively charged particles, and basically cathode rays are made up of negatively charged particles, and these particles are known as electrons. These cathode rays, they always travel in a straight line, and as we just discussed that on striking upon zinc sulfide, they produce a green colored glow or a green colored fluorescence. Cathode rays are deflected from their path by electric and magnetic fields. This means that if whatever setup is being used for the experiment, if it is kept near magnets, or if it is kept in a place where electric current is there, the cathode rays may deflect from their path. They can change their path. They will move in some other direction. Next, the cathode rays can penetrate through thin metal foils. They can cross the metal foils, and the charge to mass ratio for the particles in cathode ray is fixed. It is independent. Whatever gas we take, whatever anodes and cathodes we take, whenever charge and mass of the particles we divide them or we take their ratio, it is going to be a constant number always. This means that the charge and mass are always constant. So charge on an electron is 1.6 into 10 raised to power minus 19 coulombs, and mass on an electron is 9.1 into 10 raised to power minus 31 kilograms. These are important values. We need to memorize them. Moving on to the next part of the video, discovery of protons. So in 1886, Goldstein again carried out an experiment. What he did was, he just, instead of taking perforated anode, he took perforated cathode. That means the holes that were made, they were made in cathode apart from making it in the anodes. Again, the setup was same. In discharge tube, air was taken at a very low pressure. Vacuum pump is there to regulate the pressure of the gases. Discharge tube is made up of glass, and we have metal electrodes which are attached to the high voltage generator. The negatively charged electrode is called cathode, and the positively charged electrode is called anode. But this time what is found was surprising. What was found was that instead of rays coming from cathode, now the rays are coming from the anode side and they are moving towards the cathode side. So when this happened, perforated cathode helped to check whether the particles or the rays are being emitted from anode or not. Again, a zinc sulfide layer was kept at the back of the cathode and a red glow was produced this time. Since the particles are moving towards cathode, that means they are moving towards negatively charged electrode. It was assumed that the rays that are being emitted from anode, they must be carrying positive charge, or they must be carrying positively charged particles. Again, whatever we have discussed, let's just read it once again. Characteristics of anode rays. So anode rays consist of a stream of fast moving positively charged particles, and these positively charged particles were known as protons. Like cathode rays, they travel in straight line, and they also get deflected by electric and magnetic fields like the cathode rays do. They can also penetrate through thin metal foils, and the charge to mass ratio for these is fixed and very small. Charge on a proton is same as that of charge on electron, but there is the only difference that electrons carry negative charge and protons carry positive charge. So the charge on proton is positive 1.6 into 10 raised to power minus 19 coulombs, and mass on proton is 1.67 into 10 raised to power minus 27 coulombs, kilograms. Moving on to the last part of the video, discovery of neutron. Neutron was discovered by Chadwick. Now before we actually discuss what experiment he took to carry out the discovery of neutron, let us discuss what inspired Chadwick to perform the experiment. As we already know that electrons and protons are the subatomic particles of an atom, and electrons are present in the extranuclear region while protons are present in the nucleus of the atom. Also, the mass of proton is very large in comparison to mass of electron, or we can say that the mass of electron can be neglected in comparison to mass of proton. So this means that whatever is the mass of atom, it is because of protons. But it was found that the mass of protons is less and the mass of atom is more. In fact, the mass of atom is almost the double of the mass of the protons. So Chadwick thought that there must be some other particles present in the atom which may not carry any charge, but they must be having the mass equal to that of the proton. And then Chadwick performed an experiment in which he striked fast moving alpha particles on some elements. And he found that some particles are being emitted which carry no charge and have mass equals to that of proton. Such particles were later on named as neutrons. So this is how electron, proton and neutrons were discovered. Electron was discovered by a discharge tube experiment by William Crookes. Proton was discovered by again a discharge tube experiment by E. Goldstein, and neutron was discovered by Chadwick. Mass on an electron is 9.1 into 10 raised to power minus 31 kilograms. Mass of proton is 1.67 into 10 raised to power minus 27 kilograms. And mass of neutron is also 1.67 into 10 raised to power minus 27 kilograms. Neutrons carry no charge. Both electrons and protons carry a charge of 1.6 into 10 raised to power minus 19 coulombs. The only difference is electrons carry negative charge, protons carry positive charge. The magnitude of both the charges is same. So with this, we have covered the discovery of electrons, protons and neutrons. Okay, one question for all of you. Which particle out of the following will not get deflected by electric and magnetic fields? Your options are electron, proton, neutron. So you have to tell that which of these particles, if kept in electric or magnetic field, will not deflect while the other two will deflect. I hope you understood what we have discussed in this video. Any doubts can be taken anytime. Thank you. Have a nice day.